Okay, thank you, viewers. You are always helping our channel to grow and grow. So today we are going to look at osmosis in plant cells. Osmosis in plant cells. So this is what we are going to look at today. So I'll try to draw three things so that we may brief. Okay. I'm drawing a plant cell. I'm drawing a plant cell. That is it with a plant cell. Okay, so here okay, so here this is cell wall. That is cell wall. From there we have the nucleus. Then we have cell membrane. We have cell membrane. Cell membrane. Okay, then we have vacuole. Okay, so this is just an illustration so that I can now try to explain. So how is osmosis in plant cells? So here we find that in plant cells, where we have hypotonic and hypertonic. So here you find that in hypotonic, when this plant, this one, the normal plant, when it is placed in an hypertonic solution, it will gain water, because hypertonic meaning the water concentrated outside enters inside the cell. That is in a brief definition. So now here you find that the water will enter inside the cell. And when the water enters inside the cell will become like this one, meaning the vacuole will grow, the cell membrane will reach where the cell wall is. And here, okay, just on this one. So, and the cell membrane will reach where? Inside where the cell wall is is. Now for this one, the cell membrane will not burst, or the cell wall will not burst. The cell membrane would attach itself to to the cell wall. The reason is simple. The cell membrane will not burst because it will attach itself to the cell wall, and the cell wall will not burst because it is hard, because it is made up of cellulose, meaning it will not burst as the cell membrane is, meaning the cell wall is harder than the cell membrane. The cell wall will just remain at its position. It will not grow big or grow in size, or the size reduces. No, it will just remain the same. So now, what we need to understand is that when the cell is the water has entered inside the cell, then the cell swells, it gains the water. That cell inside the water, the concentration will be high inside than outside, because outside at first the water was concentrated, meaning the water will enter inside the cell where it is less concentrated, and it will result, when this happens, it will result as protoplasm will take place. The cell membrane will press itself to where? To the cell wall, and that is called protoplasm. From there, the condition now where the protoplasm of the plant cell possesses against the cell wall, when it gains water, it is called turgidity. So now, here when the cell membrane moves, swells, it swells and it grows bigger, that is called protoplasm. Now when it attaches itself, the cell membrane attaches itself to the so when this it starts growing bigger, it is called protoplasm. Now when it attaches itself with the cell wall, it will undergo what we call turgidity. So when the cell membrane attaches itself to the cell wall, it is called turgidity. When the cell membrane, because of water it gains, it swells up, that is called protoplasm. So that is what happens when the plant cell is placed in in an hypotonic solution. So now, what happens when the cell is placed in an hypertonic solution? So here those are the same. So now that's only hypertonic solution. What happens? So here we find that this cell, the normal cell, when it placed in an hypertonic solution, it is normal the way it is. It is normal the way it is. So this is the nucleus, this is the vacuole, the cell membrane, the cell wall. This is a normal plant cell. Now when it is placed in this hypertonic solution, what happens is that it will undergo something which is very, 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 very interesting, but dangerous to that living organism. So here what happens is that when this cell is placed in hypertonic solution, the thing is that because the water will go outside the cell, meaning this cell membrane, it will swell, and as it swells, it will be like this. It will shrink, concentrate, coming together to attach itself, but it will not do that because it has a line where it belongs. So now what happens is that when this happens, this cell will lose the water, and when it loses the water, it will undergo the process which we call plasmolysis. So plasmolysis, meaning this cell has been plasmolysed. This is what happens in the plant cell when it is placed in in an hypertonic solution. So that's why the plant always needs water. When the plant lacks water, it will wither, and we know that we have two different kinds of wither, whereby we have permanent and temporal. For temporal is whereby it withers, but when you pour out water to the cell, you find that, or to the plant, it will grow strong again, or it will be at a normal stage where it needs to be. But permanent, even if you pour much water, you add fertilizer or anything, that plant is dead. So that is the bad side of the cell losing the water. So each and every time the animal cell, the plant cell, these needs to have no more water. So now the last one is isotonic. Isotonic. So in isotonic, in a plant cell or in an animal cell, you find that here is a cell, here there is concentrated water, and here there is concentrated water, meaning the cell cannot go and the water cannot go inside, or the water go outside, because outside and inside the concentration are equal, meaning there is equilibrium, meaning the water cannot move outside or inside the cell, meaning the cell will be at a normal rate. So that is the same also with a plant cell. So please, if you like the video, like, subscribe, and share to others. This has been your teacher, Mr. Capella, in Biomathematic Academy. Thank you so much. Continue watching as we make our journey and our channel to grow bigger as bigger.